Children, let us see today areas of similar triangles. It is given as the sides and altitudes of similar triangles are in proportion. These are some of the properties of areas of similar triangles. So let us take two triangles which are similar to each other. So if they are similar, already we have seen many properties they satisfy. Among them, this is one another property, and what it says in triangle PQR and triangle ABC, we have altitude, children, and we know the altitude makes a right angle with the base. Altitude is nothing but the height of the triangle, children. So that means if you are taking it as S and D, PS will be perpendicular to QR and AD is perpendicular to BC. So the property says to us that PQ, the proportion PQ upon AB is equal to the ratio of the sides and the ratio of the heights of the first triangle is PS upon AD. They are in proportion. So if we consider a side S1 and H1 denote side, we can take any one side, children, a side and height respectively of one triangle and S2 and H2 is a side another side and height respectively of the second triangle, then what we can write, children? A general form we can write it as, so it is a general form, children, of another triangle. Then we can write it as S1 upon S2 is equal to H1 upon H2. So this not necessary, children. Always you have to take PQ, even you can take QR, and even you can take PR. So these things can be remembered in your mind. It can be PQ upon AB, either it can be QR upon BC, or it can be PR upon AC. So this is one of the property. Let us see the theorem of areas of similar triangles and what it says. The ratio of the areas of two similar triangles. So if we take two similar triangles, let us say triangle LMN is similar to triangle DEF. Children, already it is given that these two triangles are similar to each other. So LMN and DEF, let us say, and it is given that both the triangles are similar to each other. Then what the theorem says, areas of two similar triangles, means you have to take the ratio of the areas. Area of the triangle LMN upon the area of the triangle DEF is equal to the ratio of the squares of the corresponding sides. So if we take the side of the first triangle as LM, so LM the square upon DE. How the sequence of the names you have taken, so will be the sides, children. Will be equal to, now next two sides, MN, the square, upon EF, the square, will be equal to the third one. Let us take, children, LN, the square, upon DF, the square. So this is a theorem of areas of similar triangles, which we have to remember in our minds while doing the sums. So let us do some sums. Practice set 1.4. It is Geometry Maths 2. The first question is given. The ratio of corresponding sides of similar triangles is 3:5. Now let us see. These two triangles are similar to each other. Already it is given to us. ABC triangle is similar to DEF triangle. Fine. So if, let us say, A1 and A2 are the areas of the two similar triangles, and we have to write these statements, children. If we take S1 and S2 as their corresponding sides, so we have, by the property of the areas of similar triangles, we have the area of the first triangle upon the area of the second triangle will be equal to the ratio of their squares of the sides. The ratio of the squares of the sides. The ratio of the areas will be equal to the ratio of the squares of the sides. So already it is given, the ratio of corresponding side of similar triangles is 3:5. So therefore A1 upon A2, the ratio of the areas will be equal to 3, and this can be written as S1 upon S2 the whole square. And what is the reason over here, children? You have to write the reason compulsorily. Theorem of areas of similar triangles. Fine. So 3 upon 5 the whole square. It is given as A1 upon A2 is equal to 9 upon 25, the answer. Understood? Now let us go to question number 2. What is already given to us in this question? The first one, see. It is given that two triangles are similar to each other, and the ratio of their corresponding sides is already given. So by the theorem of areas of similar triangles, what do we have? By the theorem of areas of similar triangles, what do we have, children? The ratio of the areas of the two triangles is equal to the square, the ratio of the squares of their sides. So it can be written as AB upon PQ the whole square, that is equal to 2 upon 3 the square, and that gives us 4 upon 9. Hence A1 upon A2, if we take the areas as A1 and A2, will be equal to 4 upon 9. Alright. Similar manner is the third one, children. What we are given with C1s, ABC and PQ are both similar to each other, and areas are already given to us. then we have to find the ratio of their sides. If the ratio of their sides is AB upon PQ they are asking, so we can write it as by the theorem of areas of similar triangles. What do we have, children? We have the area of the triangle ABC means the ratio of both the triangles is equal to the ratio of the squares of their sides. Okay, so let us find the ratio of the squares of their sides, because already the areas are given to us. The first one is 80 upon 125 is equal to AB upon PQ the whole square. So what we are left with, the whole square comes to the left hand side and it will become as square root AB upon PQ. So the square root of 80 and the square root of 125 we have to find, children. See, how do you find it? 80 if you find 40, 20, 10, 5 and 1. So the pairs 2, 2 will give you 4 root 5, and for 125 similar manner if you find, you will get it as 5 root 5. So this is 5 root 5. So write it 4 root 5 upon 5 root 5 is equal to AB upon PQ. Hence AB upon PQ is equal to 4 upon 5 is your final answer. You understood how you got it? So this is the third one what you have done.